Right. Okay, I think it's just going to be a good time to start. I think everybody who wants to join the presentation can join their own accord. Of course, it's going to be 2 hours, so let's see how it goes. All right, well, welcome you guys for joining the first Bitcraze tutorial. Of course, it's all going to be recorded eventually, so don't worry about missing anything of it. So here are some technicalities. So for people joining both in Discord and Mozilla Hubs, please ask the questions in the tutorial chat. Also, Mozilla Hubs, try not to have your voice on unless we're actually in break or in the socializing hour. And yeah, and if, as I said before, if you hear an echo, you probably just have to mute either Mozilla Hubs or Discord. And like I said before, this all is going to be, the full tutorial is going to be recorded and it's going to be available for viewing eventually on the event page. So let's begin. So just a very quick introduction to people that don't know Bitcraze. I hope you guys do, but you never know who shows up to this tutorial. So of course, we are known for making the CrazyFly. We're a company that makes hardware development, and we're here at Malmö, Sweden. It's now 6 o'clock in the evening. So of course, it's difficult to accommodate for everybody that's all over the world. But we also heard so even people from the East here. So we're very happy with their dedication to join this presentation. So all the team members is Tobias, Marcus, Christopher, Arno, and Barbara, and my name is Kimberly. So yeah, that's us in a very quick nutshell. This is how our current lab look like, and we're going to set up the nice demo right here for you. All right, so let's continue in the presentation. So the CrazyFly is a quad rotor. It has 4 rotors and 4 motors. And it's mostly being used by hobbyists, researchers, educators in area robotics or shows. It has open source firmware, and we use the CrazyFly has a modular design. So my modular design is actually that you can kind of configure the CrazyFly to your own needs. So that's the idea of the CrazyFly. You can just add new decks on it, and then change the sensor configuration so that you can use it for your own research. So like, for instance, the CrazyFlies that we're going to use for today have the Lighthouse Deck on there, and we also have a QI charging deck as well. So, and this is actually the positioning system we're going to use. I'm going to tell about that more later. So our demo in a nutshell. So we use the Lighthouse positioning system. We use about 9 CrazyFlies. We're going to set up that all right here, and we're going to use charging station for them to charge their battery, and we also have some communication through a computer. So I'm going to explain all of these elements while we're going through the demo right here. So during this presentation. So we've usually been showing this demo during our conferences, actually. So that's this is a nice video of that right here during ICRA. That's almost yeah, feels like ages ago now. Oh. So that's pretty insane. So it might be a bit choppy, but here you can see it flying in a 2 by 3 meter cage, and yeah, also flying about 8 or 9 of them. And there, with that, we were able to show people at the conference what the CrazyFly is and explain them all. While we're actually like, we didn't even have to look at the demo itself. It was just going fully automatically. And that was the nice thing about this demo. So that's why we're going to explain how you guys can also achieve it as well. All right. So yeah, so this is going to be mostly the topics for today. We're a bit behind schedule, but let's see how quickly we go through this. First, going to talk about the Lighthouse positioning system, specifically about the base station V2. And then we're going to ask a couple of questions. Some of you have already submitted answers before, so we have also a nice list of those. Then we have about a 15-minute break. The time is not correct here. It should actually say 18:45. I'm sorry about that. So it's going to be a 15-minute break. And then at 7, we're going to actually talk about communication, sworn autonomy, a bunch of these things, and also have a question. After that, we hope to meet you guys and maybe Mozilla Hubs or just in the chat. So yeah, so that's going to be our event for today. Let's see. So these are kind of an overview of the positioning system that the CrazyFly can actually use for flight, because it needs to know where it is. So you can either use relative positioning, which you can do with the flow deck that has a motion sensor in there, is able to determine its own velocity. And also, of course, we have absolute positioning. So it's actually using an external way of detecting his own position. So we have the LPS positioning system right here. Here is mocap systems, as probably many of you know, and here we also offer the Lighthouse positioning over there. There's also a difference between onboard estimate and offboard estimate. Mocap usually uses an external computer to do estimate the position offboard and then send it to the CrazyFly by some means. But both the LPS, the ultra-wideband based local positioning system, and the Lighthouse positioning system actually enables the CrazyFly to estimate its position on board. So that's what we're going to talk about, the Lighthouse positioning system, because that's what we use during our demo. So they're mostly developed by Valve Corporation. You must also probably also know them from Vive as well. And these things are called base stations. So technically, they are meant for virtual reality. So here's a nice photo for me being in virtual reality. Yeah, so we started about 3 years ago of developing for the Lighthouse system, but still it's in early access because it's not a super easy project to work with. But it has millimeter precision. There's a little typo right there. I'll fix it later with the final slides. Let's see. So, by the way, I've noticed that some of you are saying that the screen in Mozilla Hubs is not that great. We noticed that the stream is not as quick there. So if you don't like the stream, you can also decide to just go out and go back to Discord, or go back then for the break and socialization. So that's totally up to you. All right, let's continue. Okay, so before, like the previous slide, I was talking about the V1 and V2, because it's actually 2 versions of the base stations positioning system. And they work in different ways. So the V1 actually has 2 rotors that controls 2 light planes. So 1 rotor per each light plane, and 1 for the horizontal, 1 for the vertical. So the base station V2 actually just have 1 rotor, which controls both light planes. So that's the main difference between V1 and V2. We also have a nice visualization right there. Hope that it's visible in Mozilla Hubs as well. So you can hopefully maybe see more clearly what the light planes are actually doing in both V1 and V2. All right, so let me just very quickly. Yes, there we go. So just to make the screen a bit bigger in Mozilla Hubs. And let's go to the next page. I hope it's a bit clear. Okay, so how do you go from the light sweeps to the sensor of the CrazyFly? So that's what this Lighthouse Deck is doing. It's actually receiving the these light sweeps from the base stations that it's receiving on the sensor. So technically what we're getting after all the processing and everything is the angle on which the base station sees the CrazyFly at that moment. All right, so as you can see in our demo setup, it's still very empty hall. So we're going to actually set up the base stations for you guys. So if I can look at my lovely assistant. So technically from what we're going to do now is just to put the base station in position. Yeah. And we actually have them already on tripods right there. Yes, perfect. Okay, it's maybe not the most exciting demo yet, but it's all going to be completely worth it in the future. So they have they just have a single chargers, and they don't need a syncing cable. So these are the base station version 2. Usually with V1, you do need a syncing cable usually between them, or if they're actually watching each other, then it's fine. But that's kind of also the difference with setting up the base station V2 and the V1s. All right, so I also have a CrazyFly right here, so I can actually show some. Could you put it in the middle, Tobias? Or just turn it on? And yes. All right. Let me power up a sea of clients, so I can actually show you guys the raw angles that we're receiving from the CrazyFly. Yes. By the way, in Mozilla Hubs, stop playing with the screen, please. All right. So I hope everybody's able to see this. So let me just see if I'm able to show some raw angles. So these are actually in radians, I believe. Yeah, pretty sure those are in radians. And these are the raw angles that a single sensor on the Lighthouse Deck is receiving from both sweeps of the base station. So yeah, so that's those are the raw angles. Yeah, and Tobias is now going to move them around, and then you can actually see the angles changing on the base station. All right, thanks a lot. Okay, so there's this tutorial is not going to be super super into the theory of actually how very into the details how we actually precisely implement this, but there's two methods that you can actually go from the lighthouse angles to position. The first one is crossing beams. So you pretty much are taking the vector from the crossing sweeps of the base station, and then you need two base stations to actually then get the 3D position of the CrazyFly. You can also use the raw sweeps, where we use actually a measurement filter of the measurement model in the extended Kalman filter in the CrazyFly. The nice thing is that you don't necessarily need one base station. They're pretty much decoupled. If you want to find more about like the exact implementation details, the equations and everything like that, please go to our documentation listed here. So that's documentation, system overview, positioning system, and Lighthouse positioning systems. And yeah, let's see where we are right now. Yeah, okay, great. What we are going to go a bit more into is actually calibration of the lighthouse, because there is actually quite a lot of details that are worth mentioning. So because the light sweeps are not perfect, and that's due to reflection of the glass of the base station. Is due to like the motor calibration of the rotor where the light sweep is actually connected to, and diffraction of the curvation of the glass in general. So, okay, I'm going to show to you how to actually, how you're actually able to get this calibration data from the base station itself. Let's see. So I hope that everybody's able to see the code clearly, but you go to Tools, Lighthouse, and then you have all kinds of tools here for Lighthouse, which we're going to go through in this tutorial in a bit. First have to know where, because you need a micro USB to connect to the base station. This is currently the base station V2. Let's see at which port it is. Yeah, obviously it's that port. And then we need this one code right here. Right, Python get. Let's see. Get. Let's see. Probably you're missing a slash right there. There you go. So now we get a bunch of values there. Actually, the CrazyFly is able to receive these calibration values as well. But we're going to explain it a little bit in the next slides. It takes a little bit longer for the V2 to receive those calibration values than the V1. All right. So we're going to eventually use this calibration values to flash to the CrazyFly. So that's going to happen in a bit. What I can also show to you is actually how to change the mode of a base station permanently. So that's actually if you do pico com def tty acma 0. All right, and then mode. Cool. It's currently in mode 3, so I maybe want to go put it in mode 4. By the way, the base station that we have open here and there are base station 1 and 2. So that's like at least if you want to configure it for yourself. So I want to put this to mode 4. All right. So let me just check that. It's now currently mode 4. And if you want to save that, I think you have to do to save. Yes, that's so, because if you would turn off the base station, this mode would actually not be saved permanently. So you actually have to do param save. So that's just a nice trick how to actually change the base station mode without actually changing it in Steam VR. Which is also a nice trick to have. Like I said before, so this is only necessary for base station V2. Base station V1 received the calibration so quickly, so you don't need to hard code it at all. So technically, like I said, the CrazyFly is able to receive the calibration values already automatically if you just put it there. It just takes a little bit of a while. So we can maybe check out the console a bit. Nah, it didn't receive it there. So we definitely need to hard code this, for sure. Okay, next. So the calibration values, you already saw a couple of names there. Let me just explain it a little bit more in detail. So you have things that are involved to the rotor calibration. So that also is also holds for V1 as well. So the tilt is pretty much the error of the light plane tilt. So for V2, it should be at 60 degrees. So it might be like the calibration might say, okay, it's probably 61 or 60 or 59. So that's the tilt error. The phase error is actually the error that involves with the rotating of the motor. So that's yeah, it pretty much stands for itself. So we also have things that have things to do with the distortion of the glass plane. Oh wait, I saw that my face was a bit in the way. So that's how the phase error looks like. All right. Okay, so there's also some calibration values that are related to the distortion of the plane. So you have the gibbous, phase, and magnitude, which has something to do with the compression along the sweep. So if you have like the sweep like this, the gibbous phase actually says like, okay, it's more compressed here, and then suddenly it goes fast, and then it's more compressed. So this has pretty much just to do with it going through more glass or plastic. So that's pretty much what it's going for. The curve and the OG phase and magnitudes has something to do with the curvature of the light plane and the shape of the light plane, which is also due to where the actual motor is. So that's so yeah. Those are maybe some complex shapes that you need to try to figure out with the calibration values. But we must say these are kind of all speculations. Valve hasn't released anything of this, so we pretty much have to kind of reverse engineer ourselves. So we can kind of tell you about the process we made until so far. So we're not the only ones who've worked on with the Lighthouse system. LibSurvive is an open source project for VR, and they actually also did a calibration model themselves. You can check that right there in the code. And ours is a bit of the implementation here. I'm not going to go into detail, but you can check it out in Lighthouse Calibration.c. For V1, we pretty much use all the calibration values that's available. For V2, we actually don't use the curve and OG. Why? Because we haven't figured out how it fits in the calibration model. It's pretty good so far. The quality we have, we probably see like maybe a jump of a centimeter or so, but yeah, we don't use those values just yet because we still don't really know how to implement this yet. But for V1, it's fully implemented. All right, so let's use this calibration values that we have. Let's see. So I'm actually going to. We actually cheated a little bit. We already got the calibration values for these two base stations right here. So those are the ones that we actually show, just set up. We already have the calibration values right there, so I can just go ahead and use those. So I made a nice application in the app layer of the CrazyFly. So this is right now not available yet in the firmware, but it's very easy to make though. So currently I'm going to make my firmware with this base station geometry in there, which is then sent to the CrazyFly when initializing the Lighthouse. So yes. Now we have to wait a little bit. We probably have to wait for a couple of seconds. So if you have a couple of questions, Christopher and Tobias are waiting eagerly for answering your questions. So just go ahead, ask your question in Discord or in the Mozilla chat hubs. All right, there's no questions yet, so we just wait until this has. Usually this goes a lot faster, but because I'm running a lot of streams on my computer, it's having a little bit of a difficult time. All right, good. All right, I'm going to flash this currently to by the Crazy Radio PA. Oh, whoops, I'm still connected to it. You cannot do that at the same time. Okay, so with this I can actually make it go into bootloader mode and flash it. So let's see if it responds. Is it still on? Yes, it's still on. This will also take some while. I see that we have a question also about how much space can we cover compared to V1. It's about approximately the same space, 5 by 5 meters. But with the base station V2, we can actually add more base stations to it, or at least like that's the general design of the base station V2. So you can actually expand your tracking area to, how many base stations you have. We just need to add support for it yet. So we're going to go back to that later. Yes, okay, so it seems to be flash. So let's go back to a CF client. All right. So this now I know with the app. Okay, so what I'm going to show to you are actually the comparison between, let's see, these are one sensor and one base station with their compensated angles and uncompensated angles. That's what you're seeing right here. I don't know if you can maybe move it around a bit, Tobias. Maybe a bit difficult to see that much of a difference, but yeah. It's maybe a bit difficult to see, but it's you get the picture. All right. So we're not yet done. Oh, I actually, one moment. So I actually, after flashing the firmware, sometimes the Lighthouse Deck doesn't start up properly. It actually did now, so I'm lucky. But we also have a nice tool that you can also reboot it remotely. So that's the one right here. So you can actually reboot it remotely while you're sitting from your chair, like I do. Next time. All right. So so we've set up these base stations right here. So how do we actually find a geometry of those? So the translation orientation. We actually do it by actually treating the base station as a camera. So we translate like those the planes, if they're in V2, to X and Y. And for V1, of course, that's already the standard sweep. And then we actually use OpenCV and we use self-PNP algorithm to find the actual geometry. So go back to, first have to disconnect. Shouldn't forget that. And then we go to back to tools, Lighthouse. What's it called again? Okay, yes. Actually, we don't. It's an executable, so we can actually do this. And then we do Yuri, no, radio. Hope I remember it. 2. And E7, E7, E7. No, it's 09. All right, it's reading the sensor data. And here's actually the estimated position of the base station, actually. So what you can actually see here is the X, Y, and Z. So this is the translation of the base station. Rotation is too difficult to, so just, the only thing that you really have to look at are these 3. Do they make sense? Is it actually behind the CrazyFly? Is it actually on the top? And this seems like it's actually making sense. So I'm just going to use this actually to flash to the CrazyFly. One moment. Let's see, repeat. All right, so I'm just going to copy this. And I'm going to use that in the app. So this is a geometry that I had from a previous tryout, which is of course not valid anymore. Like if you don't have the wrong geometry in there, you'll definitely notice it's going to bump all around the place. So definitely don't do that. Yes. All right. Examples. Right, where are we? Demos, demo tweets. Okay, so we have to make this again. I'm not going to clean it, just to increase the time that we're have to wait for it to be made. All right. Let's see. So we're going to flash a little bit. While we're waiting, there's also a alternative way to actually write the geometry to the CrazyFly is if you actually use dash right in this script. If you do this right, it will actually send the geometry to the CrazyFly and put it in this memory right there. The problem is, unfortunately, if you turn off the CrazyFly, it's the geometry will actually disappear. So that's the tough part for it. All right, so let's see if it's finished. Okay, it is. And now I should reboot. Let's use that. All right, let's switch the demo. Still sending right there. I'm going to fly soon, I promise. So if we now connect to the CrazyFly, to the CF client, and we look at the position estimates. Okay, so this is actually meters. So it might look very bad, but it's actually quite good. It's so it's actually estimating position right now. So you can also see here it's maybe a little bit more better thing. It's pretty much like thinking it's on 0, because if you actually estimate the geometry, it's taking the CrazyFly as a 0 point. Tobias, if you can maybe move it a little bit, and maybe you can see a little bit of the. Yeah, there you go. Okay, that looks a little bit better. So you might notice. First, I go to the position. So you might notice. So like, why did I explain the calibration just a minute ago? Is that much of a difficulty? Well, like the easiest way to show that is by looking at the height. And if I would, for instance, turn off the calibration off, I made a parameter here for my app layer, and I turn it to 0. it suddenly jumps a couple centimeters in the air. So yeah, the calibration and that's actually going to make a difference, especially like at the size of the base stations. If you're going to go fly at the far side, you're definitely going to see a big difference. Now, yeah. So yeah, that doesn't really look good. So you need the calibration for sure. Let's put the calibration back there. Yes, now it's nice and smooth again. It looks a lot smoother now. Now we zoomed it a little bit out. Because this is, like I said before, this is in meters. Okay, so disconnect. Okay, so let's fly with this. Now we have everything ready. Let's fly a spiral. Okay, so this is a very quick look at the script. So you can also find this in our Python library as well under examples. I think it's a high level commander. I just changed it to Spire. Usually we have the figure 8 in there, but now I also have the polynomials for flying a figure. That's a figure in a spiral. So that's something similar to the demo that you're going to show, which is definitely a lot of more numbers. I'm not going to go through that, but I'm just going to show how it actually looks like. All right. Let's hope for the best. All right, so right now it's hovering. Let's see, maybe we can turn down the camera a little bit so people can actually see it flying. Yeah. Well, moments we'll have like a little zoom in on flying because currently that's not super visible. There you go. So it's flying. It's in the air, just us. All right, so it's actually flying quite stably. Means that we got the geometry quite good. And if I press enter now on the script, it actually will start flying the spiral. All right. So okay, so it flew a spiral. So we set up the base stations and configured everything, and now it's able to actually fly. So what is actually left to do? We actually are coming close to a break right here. So let's probably finish the first part. So Lighthouse v2, what is left to do? So it's early release, and yeah, it's still subject to change. All the scripts that we're showing here, we hope to actually have a better integration. It might change a little bit, so definitely keep an eye on the GitHub repository for that. The calibration implementation is not perfect. We tried as best as we can do. And we think actually that just the calibration of 1 centimeter is actually pretty good, but we are sure we can definitely improve that. So if maybe one of you guys are interested in figuring out that, so we're more than happy to get more help on that and more eyes. And I had support for more than 2 base stations. Like we had a question before about the flight area. It would be great to have 4 or more, so we can kind of increase the flight area to 10 meters, 10 by 10 meters, even more. Maybe have it through the entire office. That will be great. And or adding more support tools in the client. That will be also awesome. Okay, so yeah, so this is actually the first. That was the first hour. So we're going to actually start up setting the wireless storage and more CrazyFlies in the meantime. Yeah, does anybody have more questions? I see. How about the Lighthouse V1 calibration? Is it reliable? It's pretty reliable, I would say. It's more reliable than V2 at the moment. Definitely the 1 millimeter precision there is definitely something that we can promise more. We're just Yeah, it's a bit sad that they are going to stop supporting V1 and stop producing V1 as well. So we're now fully focusing on V2. All right. So there's also a question about Lighthouse V2 markers, and LPS could be combined in the CrazyFly decks. Okay. I remember that question from the. That is a good question. We're actually going to look at that in the next couple of months. We think so, but currently the Lighthouse deck and the LPS deck are not compatible. So that's the only problem right now. But that's actually easy to fix by putting the LPS deck to communicate through a different port and whatever. But we're actually going to work on the next few weeks. So yeah, a few months. So keep an eye on the blog post for sure. Did I miss any questions? Let me just very quickly check. Check the app. Discord. Yeah, okay, great. Christopher is indeed also answering all the questions. So let's see. So let's have a break. Let's have a break. I think that might be a good thing, especially for the people that are joining it with a VR headset. So yeah, we'll be back in at 7. So that's in 10 minutes. So see you then.